understanding the domain and the range, there's supposed to be range, there's an n missing, sorry, is absolutely crucial when you're dealing with inverse trig functions. Otherwise, if you don't understand what the domain and range actually is, you can try to find values that simply don't exist. You start getting all kinds of errors on your calculator, and you end up with things that just don't make any sense. So, as an example, I want to find y, such that y is equal to arc sine of negative 1/2. Now, I know that the domain of arc sine is equal to the range of sine, and range of sine is -1 to 1. So negative 1/2 is in the proper domain, so this works. This is fine. There should be a solution to this. Now, y is equal to arc sine of negative 1/2 only if and only if I take the sine of both sides, sine of y equals sine of arc sine of negative 1/2. All I did is took sine of both sides. Well, that implies that sine of y is equal to, well, sine of sine inverse, that's like saying f of f inverse, is going to be just negative 1/2. So what this is saying is find the angle such that sine is equal to a negative 1/2. Well, if I quickly draw my quadrants and I think about this for a second, I know that if I have an angle theta, and theta is pi over 6, that sine of theta equals 1/2. So I know that over here, where this angle is, this distance right here, this angle, the radians here is actually pi over 6, and likewise here, this is also pi over 6. That will give me negative 1/2. But now I need to think about the restricted domain of sine to begin with. Remember, the restricted domain of sine was negative pi over 2. So in this direction, this would be a negative pi over 2 up to pi over 2. So I'm restricted to angles in here. That tells me the only solution is this angle right here, which is theta equals a negative pi over 6. So if theta is a negative pi over 6, then sine of theta is going to be a negative 1/2, which is exactly what I need here. So this tells me then that y must be equal to a negative pi over 6. So that's the solution to this original problem. See, if I did not take into consideration what the restricted domain for sine was, and let me draw that for you again real quickly here. Oops. See, this is my restricted domain for sine that made it 1 to 1. This domain corresponds to the fourth and the first quadrant, because as you recall, this is 0 degrees, and when I go clockwise, I'm doing negative radians. When I go counterclockwise, I'm doing positive radians. So the restricted domain of negative pi over 2 to pi over 2 is right here. If I didn't account for that, then I would have also selected this angle, but this angle is actually theta equals 7 pi over 6. Starting at 0, coming around here, that's 7 pi over 6. Well, it's true that sine is in fact negative 1/2 there, but that is outside of my restricted domain. So the only solution is in fact right here at negative pi over 6. So let's take a look at this other example here. I want to find arctan of square root of 3. Now, recall right away that arctan has a domain of a negative infinity to infinity. So root 3 obviously fits, but the range is going to be negative pi over 2 to pi over 2. So what I need is an angle, because arctan is actually just giving me the angle. It's the angle such that tangent of that angle gives me root 3. I need the angle to fall between negative pi over 2 and pi over 2. So what I need is theta equals, oops, Steve, fix it real quick. I got, theta equals, I want to do arctan of root 3, because remember the inverse function, or inverse trig function, does give you an angle. So now what I need to do is take tangent both sides. So what I really have is tangent of theta equals, well, if I take tangent of the inverse of tangent, that is just root 3. So what I need to find is on negative pi over 2 to pi over 2, when is tangent equal to root 3. Now recall that tangent of theta is equal to sine of theta over cosine of theta. So if you don't know all the common angles immediately for tangent, thinking of it in this terms may be useful. And I also know that if theta is pi over 3, that for theta equals pi over 3, I'll have sine of theta is going to be root 3 over 2. Cosine will be 1 over 2. The 2's a cancel, and that will give me root 3. So the solution to arctan of root 3 must be theta of pi over 3. Now, these are involving exact answers because they're common angles. Very commonly, depending on the work that you're actually doing, you may not end up with a common angle. So, first thing I need to do is make sure that your calculator is set to radians. And we want to use your calculator to find the approximation for arcsine of 0.39. Well, if you just simply hit the arcsine key of 0.39 in your calculator, and it's probably, if it's a TI-83 or 84, it's going to be, this is going to look just like that, sine inverse. So sine inverse of 0.39 is actually going to give you approximately 0.4006. Depending on how many places you have your calculator set to. As a general rule, I typically work 4 places to the right of the decimal unless I need more accuracy. So that's the approximation. 0.39, this is not a common angle, so I'm not going to be able to get an exact answer off of it. Now, likewise, if I try to find arcsine of 13.3, in my calculator I enter sine inverse of 13.3, and that equals an error. Remember, the range of sine is -1 to 1, so the domain of arcsine is -1 to 1. The 0.39 worked because that's in between -1 and 1. 13.3 is not in -1 to 1. So it's just impossible to begin with. This is almost like a silly question. There is no solution to it.